busy time at the North Inlet Winyah Mir. Students come from universities all over the country to work in the field and lab. They gather data, learn new skills, and gain research experience in the estuary. Let's meet some of the student researchers from this summer.
Hi everyone, I'm Gwen Hopper. I'm a rising second year PhD student in chemistry at the University of South Carolina, and I'm currently working with Drs. Claudia Benitez Nelson and Eric Smith.
So let's start on the left. This is a picture of sweet tea, right?
So,
Unsweet?
It looks like sweet tea. You know, we're in the South, so we only recognize sweet tea, not unsweet tea.
That's right.
But this is actually a container of water from one of our on-campus locations, Strawberry Swamp. And it looks like sweet tea because there's a lot of chromophoric or colored dissolved organic matter within the sample. So a lot of my samples, this is actually the darkest one, so a lot of them have a range from a light tan to this dark brown color you see here. Going on here is that I mentioned earlier we're looking at dissolved organic matter. So what that means is the specific word dissolved. This is a whole water sample, and for us, dissolved can mean as low as 0.2 microns, and what we want to do is filter out all the large particles in the water. So this is a filtration pump that's helping us do that, so we don't have to manually do it by hand. So we're just taking our water through here, and it's going to pump it through here, which is also a filter. And then this is another filter, so we're going into
Triple
really
filtered
network here. And this is the final sample that we're going to look at that has that dissolved fraction of the water. And this large 4-liter beaker is going to be split into several smaller bottles, and we're going to do some different types of analysis on those. So some analytical analysis back when we get to the University of South Carolina, but specifically we're looking at the carbon degradation. And so we're going to do some dissolved organic carbon analysis on it.
So this water is going to travel all the way from here at the coast up to Columbia.
Yes, it'll make it that far. We'll freeze it, we'll acidify it, and it'll be good to go. What I'm going to do is I'm going to look at an incubation study of this current dissolved fraction of the water we've collected. But before I do that, I'm going to add back a little bit of the microbes in that community into this so that we can see how that degrades over a 180-day period. And so what that'll allow us to do is see how the carbon changes, and it's going to allow us to characterize the organic matter. So what characterize means is it an aromatic ring? How much nitrogen is in there? How much carbon and phosphorus is in there? And once we can do that, hopefully we know where the source of the water comes from. So is it coming from an urban and developed community? Is it coming from a forested wetland? Is it local to waters in South Carolina, or is it like the Great PD, which goes all the way up into like the northwest portion of North Carolina? And so what makes the dissolved organic matter different in different areas is that in the forest, there's less grass and there's more dirt. There's more soil, there's more sediment. In our communities where we live, where housing developments are, there's more grass. And so the fertilizers that we use, the grass that's there, any type of chemicals that we're putting in our yards in the developed and urban areas is going to go into those stormwater ponds and then that's going to go into the lakes and the rivers, and that's going to end up into the ocean. Some of the waters that we have here are coming from parts of North Carolina, flowing through South Carolina and all the way down here, and they're going to go to the Atlantic Ocean. And so we want to see what the source of this water is and characterize it.